My baby give me a high temperature.
We're in the lab testing a 175 Celsius wafer level chip scale voltage regulator. Let's start with a temperature test. We're using a wafer level chip scale regulator eval board. Because of their inherent stability, these regulators don't need any external components, not even bypass capacitors. The supply provides 7 volts to the regulator input. A meter measures the output voltage, and a thermocouple monitors temperature. A load resistor on the meter sets the output current to 20 milliamps. And the NVE regulator works fine above 125C. And even above 175C, or 347 Fahrenheit. Now a classic Warhorse 78L05 for comparison. We added input and output bypass capacitors as recommended in the datasheet. It's only rated to 125C, and the 78L05 wafer level chip scale part is only rated to 85C. And the output craters above 150C. Next, we'll test line regulation and input voltage. 2 sections of a power supply are connected in series to provide up to 45 volts. The meter on the left shows the input to the regulator. The one on the right shows the output. On the scope, the x-axis is the regulator input, and the y-axis is its output. As we increase the input voltage, it starts to regulate at 6.2 volts. It's very stable to 36 volts. And it still works at 45. Most regulators specify a maximum operating input of 30 volts or less, but DC 0X series regulators are specified to 36 volts, with an absolute maximum of a remarkable 45 volts. If we turn on the persistence, we can graph the line regulation, and it looks just like the datasheet. Let's run the 78L05 up to 45 volts and see what happens. It goes well above the 5.25 maximum output. So even if 45 volts doesn't destroy the ordinary regulator, it could destroy your 5-volt circuitry. Next, we'll check ripple rejection. We set a signal generator for a 120 Hz sine wave superimposed on a DC offset. We run that signal through a bipolar operational power supply to drive the device under test. The yellow trace is the input to the regulator, which is an 800 millivolt peak-to-peak sine wave superimposed on 10 volts DC. The cyan trace is the AC-coupled regulator output. The scope measures 800 millivolts peak-to-peak ripple on the regulator input and 3 millivolts on the output. So the ripple rejection is 20 log 800 over 3 or 49 decibels. The 3.3 volt version is even better, with 2.08 millivolts ripple for a rejection ratio of 52 dB. So the lab results are in. DC 0 series regulators have a best-in-class temperature rating and maximum input voltages, as well as excellent line regulation, load regulation, and ripple rejection. The parts are available in 5 volt and 3.3 volt versions, in a DFN or a new ultra-miniature wafer-level chip scale package. Click, email, or call us for more information, or to order parts and evaluation boards. Please like this video and subscribe to our YouTube channel.